All right. Hi, everybody. My name is Andre,
Hi, my name is Joseph.
Hi, my name is Seher.
Name is Rodrigo.
and today our group will be looking at the impact of war on climate change. And so, as we move on to the next slide, I have one thing I want to mention before we even talk about our proposal and our issue. Did you know that an estimated 280,000 metric tons of carbon has been released into the atmosphere? And in just 2 months following October 7th, due to the increasement of bombardment of the Gaza Strip, um, it's a war-torn area. Just wanted to bring it up as we segue into our issue and proposal we have for this presentation right here. So, as we've done some research and looked through different things that relate to climate change and the impact of war on it, we're looking at, what are the possible solutions for sustainability when looking at advancements towards the technologies that militaries are using. And so today, as we look over the reports of what each of our members have compiled for this presentation, we have many focuses to look at. We're also looking at how war worsens climate change. We're also going to be looking at ethical dilemmas and examining case studies that go into building these machinery, and also discussing what alternatives we can do in order to make a less impact on, not a less impact, but you know, being able to reduce the amount of emissions that's already being happening for climate change because of these weapons. I'll go pass it off to Joseph as we talk about our first subtopic.
Hello, and I'll go ahead and start on my slide. So, um, so my subtopic was based on the carbon emissions from warfare. So, a large part of warfare's environmental impact is due to carbon emissions, and something interesting about these carbon emissions is that militaries are not required to report these emissions to the UN. So they're actually one of the only sectors that are not required to report to the emissions. So the nations don't have to include them into their total emission report. And I just wanted to give an example about the carbon emissions from warfare. And a current example that's ongoing is the Russia's invasion of Ukraine, which has produced an estimated 175 million tons of carbon dioxide into the atmosphere. And so going on to my next slide, I'll expand on some of the things I talked about. And so, what is the Paris Agreement? So, the Paris Agreement is an international treaty on climate change that was signed on April 22nd, 2016. And pretty much the basic purpose of the treaty is it's to keep the a long-term temperature goal of the pretty much keeping the global surface temperature under 2 degrees Celsius from all nations. So it's commitment from all these different nations who have signed on to the treaty to try and reach this goal in order to prevent disastrous effects from climate change. And so pretty much scientists can only estimate how much carbon emissions come from the world's militaries because, like I mentioned previously, the nations do not have to report their military carbon emissions, so it leaves kind of a blind spot. And so we can never be truly, accurate on how much exactly each nation's emission are emitting carbon because there's the military sector that doesn't have to be reported, and a lot of the nations take advantage of that and don't report their carbon emissions. And that's, pretty alarming because like I mentioned, we don't know exactly how much each nation is truly emitting, just the amount of carbon they're emitting. And so going on to my next slide, the routine emissions from military operations. So the amount of carbon emissions from militaries are staggering. As you can see in this graph I have here, if you combine the world's militaries into one country, they'd have the fourth highest carbon footprint. And so when you measure that up against India, United States, and China, you could just see, just how big like all like these world's military's carbon footprint is. And this is just purely, military where you compare it to all these other nations, they're including like just not only military, but all these other sectors as well that emit carbon. So it's a pretty crazy statistic. And so even before combat operations take place, there's carbon emissions that are prevalent. And so these emissions come from routine training, like large scale military drills, testing weapons such as missiles, artillery, shells, and bombs, which all release greenhouse gases. And pretty much another thing to follow up with is militaries also indirectly contribute to climate change because of companies mining, manufacturing, and transporting weapons. So, like I mentioned, even before warfare or combat has started, they're already having quite a large quite a large carbon footprint that they're putting forth. And going on to my next slide. So now during combat, some of the sources of emissions on the battlefield come from like aircraft, such as fighter jets, different type of tanks, and different types of ammunitions that are being used. And so these fighter jets burn jet fuel. The tanks burn a lot of diesel fuel, which burn way more than any, most trucks do, or like any generic car that you drive around. And then, as shown in the image here, an M777 howitzer shoots a high explosive round, and it explodes on impact, burning up any flammable material in the vicinity. And so, of course, we know that fires contribute a lot to carbon emissions. So, and in warfare, especially with these type of shells being shot, a lot of a lot of fires get produced, which produce a lot of carbon. And another interesting fact is some nations are even like using these foreign wars to test out their weapons. So as like you can imagine, US is like one of these nations. So when they're sending weapons over to either like Israel or Ukraine, um, they are using it to help out, but like also they're just testing to see how their actual weapons would be used in a actual war scenario. So they're kind of taking advantage of this as like a test run of these wars as like their own little test run. And going on to my next slide. And so the emissions from reconstruction efforts, so carbon emissions are still being emitted even after warfare. So after all, the battling is done and it ends in which however way it ends, um, at this stage, there's a whole big reconstruction effort that needs to happen in order to, rebuild all the damaged infrastructure. And at this stage, the main source of carbon emissions come from cement and steel production, which gets, mass produced because of the urgency to rebuild the infrastructure. And these materials, such as like cement and steel, as I mentioned, are very carbon intensive. So they're just adding on to the tally of the total carbon footprint. So as you see, as I explained, even like before the war, you have the generic like emissions that the militaries are just like putting out just before even war starts. And then during the war, you have different weapons being used and different types of vehicles and planes and jets that also contribute. And then even after the war, when it's all done, there's still more added to the tally because of the reconstruction efforts. And so I'll go ahead and pass on to the next presenter, Sahar.
Okay, thank you, Joseph. So as Joseph has mentioned, we have bombardment, which is causing a lot of emissions post-war, even before the combat has started, and of course during war. However, there have been certain alternate forms of warfare which have emerged over the years and have been used as dating as far back as World War I and World War II. And these alternate forms of warfare also contribute to not only to global carbon emissions, but destroying the environment as a whole by causing lack of biodiversity and shutting down critical power grids, which forces us as a society to move on to more unsustainable options. And an example of such an alternate form of warfare is the usage of hypersonic missiles. For those of you who do not know, hypersonic missiles are missiles which travel at the speed generally higher than the speed of sound, which is Mach 1. Usually, for combative purposes, these missiles can travel up to Mach 4 and Mach 5, which is 4 times and 5 times the speed of sound. Hypersonic missiles are powered by using liquid hydrogen as a fuel source. Now, hydrogen on its own is not a greenhouse gas, as many of you know. However, hydrogen can form compounds with other gases in the atmosphere to form greenhouse gases. So if we're in the tropospheric layer, where some of the weapons which are fired are in the troposphere, what happens is that there's less OH to react with CH2. And CH2 is the gas which is already existent in the troposphere. So as seen by this image, if there's less hydrogen to react with CH2, hydrogen reacts with CH2 to form CH4, which is methane. Um, once if there's less hydrogen, there's also less OH gases in the atmosphere, which leads to the formation of nitrous oxides as well. When these hypersonic missiles are not designed with the most utmost efficiency in mind, they release nitrous oxides and also water vapor into the atmosphere. Both nitrous oxides and water vapor are greenhouse gases, and all three of these greenhouse gases, methane, nitrous oxides, and water vapor, trap 4 times as much heat as carbon dioxide does. So even though they're in lesser concentrations in our atmosphere, they trap more sunlight into our atmosphere, contributing to global climate change. So you might be wondering, we have not seen hypersonic missiles being used in the past, but trends do pose a threat to an increased usage of hypersonic missiles. For example, recently in 2020, Russia used the Zircon missile on Ukraine, which traveled in the troposphere, and because it traveled in the troposphere, there have been readings of higher methane in the atmosphere after this missile was fired. So you can already see the impact of just one hypersonic missile you just one hypersonic missile being used in warfare. But what happens when more hypersonic missiles are being used in warfare? And trends do pose to a higher usage of these missiles. For example, the Pentagon has ordered an increased budget for hypersonic weapons research in 2024, adding on to the 161 million budget which already existed. Furthermore, the Pentagon has also ordered to increase budgets for hypersonic weapons defense systems for 2024 and the year 2025. And this is because they are seeing the research that is being done by China and Russia, and they are building a defense program against these hypersonic missiles. All of these trends say one thing, and that is that in the future, we might see warfare where hypersonic missiles are used way more frequently than they are now. And given their impact on the environment, it can be extremely dangerous. Another example of alternate forms of warfare which can hurt the environment is biological warfare, which impacts biodiversity. For those of you who do not know, biological warfare is the usage of bacteria, viruses, or fungi, or other pathogens with other pathogens which are injected into certain pathogen carriers, and or just the atmosphere in general, and they are used to harm civilians. They're used to harm soldiers. However, this also harms civilian. Like that was not a Freudian slip. It ultimately does harm civilians because pathogens are quite persistent and they can mutate very frequently. And given the highly contagious nature of pathogens, they can not only go from soldiers to civilians, but they can also be crossbreed. They can also do crossbreed and cross species infections. For example, you can carry you if you are infected by something, you can carry that infection over to your pet, or to another animal that you come into contact with. And with animals, this can hurt the biodiversity as a whole, and that's where the concept of hurting and impacting biodiversity comes from. Because if one species of the food chain is impacted, it hurts the entire food chain, and an entire ecosystem can be destroyed. So biological warfare, uh, the persistent nature of pathogens and including the mutations and detections can also impact the environment in unprecedented ways by hurting biodiversity and and destroying the food chain and entire ecosystems. Now, we live in a post-pandemic world, and seeing the threats posed by COVID-19 definitely can give you some idea of how how much of a threat these biological weapons can pose. However, I for our project, we are discussing this impact from the lens of environment change. So biological weapons can now be extracted and there can now be extracted more easily because there are more advanced tools for their synthesis and replication. So because you can create these biological weapons more easily, they are more available to countries which want to use them. If such biological weapon is used against a country, there's obviously going to be issues with vaccine supplies. We have seen in the COVID-19 pandemic how vaccine supply was already an issue for many developing countries. For us, living in a first world country, we were able to get vaccinated quite easily. But for other developing countries such as India, there were massive issues with the vaccine supply chain, which allowed COVID-19 to mutate and form stronger, more harmful mutations and variations, which harmed more people and even some animals, as there are cases of that being reported. So bottom line is that biological warfare causes destruction on such a large scale that it can hurt entire ecosystems. There also happened recordings of large scale destruction in the past, where in medieval times they used to pollute an entire river or a water source that nearby territory used to drink from. And this not only hurt the residents of that territory, but the entire ecosystem of the river itself, because the river was polluted. And now, advancing into modern times, this pollution is going to be done in the form of pathogens and viruses. So, biological warfare, another example of that would be technological or cyber warfare. Cyber warfare includes cyber attacks on critical industry and infrastructure, which includes power grids. So if we're used to using power grids for our fuel supply and electrical power lines as our fuel to power up our computer or devices, electricity is more or less sustainable in nature. However, what happens when those electrical systems are shut down? We are forced to go back as a society to use fossil fuels and coal and natural gas, which are all huge, which all can be directly targeted to greenhouse gases and increased emissions of greenhouse gases. Furthermore, these cyber attacks are also done on wastewater and waste management systems. For example, the image that you see here is of a wastewater system in Texas, which was attacked, allowing wastewater to flow freely into a clean body of water, polluting that clean body of water as a whole. So if these systems are under attack, we can expect increased rates of water pollution, and which can ultimately harm the soil itself, and harm the structure of the earth if it is done on an increased scale. Technological warfare does not always also include attacks on such power grids and wastewater management systems. These attacks can also hurt LEED certified buildings. For those of you who do not know, LEED certification is a specific certification for a building that is more sustainable and more green in nature. For example, our student union is a LEED certified building. Cyber attacks make such buildings unable to operate because it is so much easier to attack on an electricity and power grid operating system, which is usually what is inside of these buildings. And cyber attacks can attack these, and this inhibits these buildings from following their sustainability goals and getting the LEED certifications down. So if bottom line of cyber attacks is that cyber attacks are used to are attacking electrical grids, and once you do not have electricity to operate on, we as a society are going to go to more unsustainable methods of living and unsustainable methods of consumption, which can furthermore hurt the environment in unprecedented ways. So even though all the three alternate forms of warfare, which I have mentioned, do not directly contribute to climate change, their secondary contributions to climate change cannot be negated just because of how impactful they are into leaving not just greenhouse gases, but impacting biodiversity and hurting our ways of living in living sustainably. So now I'm gonna give it to Andre, who will discuss about some of the ethical dilemmas that come with working on these technologies.
Cool. Thank you so much, Sahar, for your part of the presentation. And now, as we look at another topic towards impact of war on global climate change, the next topic I personally did research on and want to talk about and propose is the ethical dilemmas that engineers face when going into weapons productions. The reason why I want to personally touch on this subject is because of looking into, the more personal picture of weapons production. I think even though it creates such an impact on an environment towards emissions and other negative elements affecting our world, I also think that it's also important to acknowledge the people who are responsible for these weapons and kind of seeing their point of view of are they even comfortable with, making these weapons they may feel uncomfortable with making, or are they just doing this to get paid, you know? And so the topics I want to present and kind of think about for this perspective is the idea a more common sense versus the principle of utility. Like I was mentioning earlier, there are some people on a scale where those who are making weapons kind of have to deal with this kind of dilemma of, am I making this weapon knowing that it can be used for mass destruction on other places, knowing what they put into it, like what Sahar was mentioning, with those different elements that can create negative emissions? Or are they also producing this on the other side, saying, we already know what we're putting into this production, and we already know what the cost is, and also what it's going to affect. We are just doing this essentially just as a career and doing this for a job. And it kind of goes back and forth with each other of, depending on who the person is responsible for making those weapons. Obviously, with those individuals, you know, producing those weapons, we also have to think about what they're putting into those weapons and creating all those negative emissions onto the environment. And so, I think what's also so important with just acknowledging ethical dilemmas is on top of the people making these blueprints or even producing it in factories, and also kind of have to deal with sending it to different people. Who are these people that they're sending it towards? What are they using it for? And what's their intent on what these weapons can be actually used for? You know, you can think of it as, depending on different people use it, like the Navy or even other countries, are they using it for, for offense, or are they kind of using it for defense towards themselves to protect them from different other battles that may come towards the future? All these different kind of figures kind of come into play when thinking about those ethical dilemmas that engineers may face. And so, kind of putting in more smaller perspective in terms of United States. As we move on to the next slide, I'm actually going to talk about one of the biggest organizations that move forward with a large engineering process that focuses on producing weapons, and that is actually the U.S. Department of Defense. So, kind of acknowledging what their role is in this whole spectrum is, they are basically responsible for creating, weapons meant for war, and also meant to destroy. Obviously, if there's ever a war that calls out, they have the needed weapons to go into battle. And so, obviously, kind of looking into the perspective of the US, this has to be one of the biggest organizations in the US. And so, when kind of putting into perspective how many people are actually part of this organization, um, I've come to look that over 100,000 engineers are involved in the process of producing weapons. And so, one thing that maybe kind of think about, how are they getting so many engineers to be involved with the production of the weapons for this department? And come to find out that um, the you know the Department of Defense actually this this kind of flowing pipe of where they are always granting scholarships and also opportunities like internships for students to join this program provided through their schools and all those different things just so that they're better prepared to kind of you know, put them into the workforce right after they have graduated with their college in either bachelor's or master's. And so that's how they're able to get more engineers into this on board with making weapons. And so, looking to these pictures right here, are kind of two ways that the U.S. Department of Defense has engineers kind of making these weapons. And so, as we look at the first picture above, it's not realistic, and it's because it's actually a 3D model of a tank. And obviously, with the advanced technology that we have now and engineers' capabilities, we are able to, you know, already have 3D models of these tanks and already know ahead of time how much of an impact they can already create, how much willpower they can have and kind of go through when going into the battlefield. And obviously, they can already notice ahead of time before production even starts, which can be good, can be seen depending on the person, a good thing or a bad thing. Obviously, it can be seen as a form of defense. Others can see it as making it a more negative emission onto the environment because of all these different weapons they use to cause explosions, destruction on other people's territories or lands, and so forth, and all also the deaths that also are also caused with that, you know. And so I also wanted to put into perspective this other picture because I also wanted to bring up how a Navy ship down here is also one of the main things that the U.S. Department of Defense is also known for making. Obviously, with those Navy ships, they have a bunch of jets, they have a bunch of weapons instilled in those, and obviously a lot of boarding space for people to transit from the space to pace, kind of guarding their borders of other neighboring countries. And so, obviously, with the U.S. Department having engineers be responsible for the investment in their techs, you know, we can they can be responsible for how deadly, but also how safe it can be for those weapons to be made for future generations moving forward. And I just kind of wanted to bring it up just because you think that other companies would be bigger in making weapons like these, but it just makes the most sense that the Department of Defense has this. So, as we move on to the next slide, I want to put more into perspective how nuclear reactors are kind of being into play today in just kind of like in the world in general. And so, what I have here in the graph to kind of represent that is just kind of show that subtle change that we're having to really reduce that um, emission that's affecting our environment. And so when we look at this graph, you know, I think besides tanks and bombs and all that, I think one of the other weapons that really affect our environment in a negative way are nuclear reactors. Obviously, they're responsible for other weapons in the nuclear field, producing those type of weapons. And so, when putting this into perspective of different decades we've gone through, this graph essentially talks about how many nuclear reactors are in the world. And so luckily for us in this generation that we're currently in, we still have under the green, we still have nuclear reactors are still being constructed, but thankfully it's not as much as it used to be, obviously towards the 60s until the 80s. Obviously, during those times, we were heavy on war. Looking into the US, for example, we got World War II, and other countries obviously trying to battle and think of more weapons that they can produce with these nuclear reactors. So to kind of put everything we talked about in a more broader perspective, I'm glad to acknowledge and find this research to show that we have been lessening the amount of nuclear reactors we have in the world, and so engineers have more they have less to worry about in terms of this field in producing nuclear reactors. As we move on to the next slide, the next one I want to talk about is if it ever comes to the case where the weapons have already been produced and it's out of the engineer's hands and ultimately up to, those people who, have those weapons, just to kind of think about the state of how other individuals who may be affected by these negative effects of war, and just think about this theory called the just war theory. And so we have it here through a case of six steps. We have the last resort, just case, valid authority, probable success, and proportionality and exit strategy. And as we look at those six different steps, these are the steps to kind of assess if using the weapons that engineers have made is really ethical enough to use to declare war in a sense. And so when looking at the six steps, we have first one, last resort. Putting this in perspective, is this really the last resort that is the last resort we can do to start war? Is there something else that we can do? Communicate, have a treaty before just using going off into war. A just case is on top of finding a last resort, is there a just case to make this all justifiable? Um, just how that's phrased. Is everything that was mentioned to even declare war justifiable and see what can those outcomes become? Valid authority, validating and making sure that the people who do want to start battle are the ones not having obviously illegal weapons being produced by them and are being used in the sake of protection rather than offense. Probable success, kind of looking towards the future if is this actually something that we would succeed in if war was called and just not doing it out of just doing it out of a single call and really just making sure what is the true outcome if war were to break out and before everything to affect our environment even happens. Proportionality is also just looking at how capable is that said person, place, or thing with the amount of supply they have to even cause all this battle. And lastly is exit strategy. What are they going to do to see if all if everything becomes lost, what is the last thing to do if um, both one side is winning against the other? And so I just want to bring up those different cases just because obviously there's just so much more in behind the scenes before um, all these negative things can happen to environments. So by looking into the perspective of the builder and what they're able to think about inner morality, and then making these weapons and seeing where they're produced to, if it's for the better or for worse, I think it's just so important to see that. Just kind of seeing it in a way um, where weapons are used for protection depending on place, but also seen as if anything ever comes to worse, kind of like the Discord theory, we have these in store. And so that is my portion. I'll be now passing it to Rodrigo for the next one.
Wait, okay. Um, for my part, a question that I'll be asking is what actions can be taken against the weapons of mass destruction? And some ideas that I found from the research are it could be treaties, acts that are focused on preventing weapons from being used or deployed, and preventing any spread of illegal transported weapons or technology, such as weapons of mass destruction. And you may ask, what are weapons of mass destruction? It is a device that is that can cause serious injury or death to many people through the use of nuclear, chemical, and biological means. Next slide. What are treaties? A treaty is a legally binding agreement between two or more countries or between a country and an international organization that is governed by international law. And one of the treaties I'll be talking about is the NPT, the Nuclear Non-Proliferation Treaty, which prevents the spread of nuclear weapons or any weapon technology. And their goal is to achieve the goal of weapons of mass destruction, disarmament. And another treaty that I'll be talking about is the Treaty of Prohibition of Nuclear Weapons, which this treaty also prohibits the deployment of nuclear weapons on national territory under its jurisdiction or control. And lastly, peace treaties, where I that's more of a political standpoint where I'm not too informed on, but I do but I know that's not as easy as it sounds, where the two parties come together and just agree to stop war. I know there's obstacles to coming to an agreement between the two parties, but if it was that easy, I would think it would reduce the amount of wars and hopefully reduce the amount of weapons being deployed and having not to use weapons of mass destruction on the battlefield. Next slide. And what acts can be placed on weapons? One of the acts that I found interesting was the Disarmament Act, which is an act of reducing, limiting, or abolishing weapons. With also, there's a there's a brew 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 of ADS, which stands for arm control, deterrence, and stability, which their goals is to assist the United States and other nations in negotiating arms arms control and disarmament treaties and creating strong relationships with other nations to aid in implementations of treaties. The next one would be non-proliferation, and which is arms control, disarmament, which are and with all these are essential tools in preventing the use of weapons of mass destruction and the spread of any weapons and the delivery systems. And lastly, uh, the no person policy will come my attention because this entails that the United States could not pledge that, well, the United States could pledge that it would never be the first to use nuclear weapons, and regardless of any circumstances. And doing so, it can reduce the risk of going to nuclear war. Next slide. And lastly, how to stop trafficking of weapons. Uh, One of the things that I found was PSI, the Proliferation Security Initiative, which uh, which helps by endorsing countries that agree to work together to impede or stop shipments of weapons of mass destruction related materials to or from states and non-states. And many P or many PSI endorsing countries also have a ship boarding agreements to let them carry out searches and seizure and seizures of material on ships that are and seizing material on ships that are pretty much keeping safe from other countries. And next would be the IMO, the International Maritime Organization, which is a specialized agency with responsibility for safety and security of shipping and prevention of marine and atmospheric pollution by ships, where I read that they were working together to to prevent any trafficking of weapons, where was introducing their practices to pretty much sniff out any unusual weapons or cargo on these ships. And another thing that I found interesting was the technology that they use to find these weapons would be like that I found was thermal cameras for nuclear weapons or materials or technology. And lastly, ISN, the Bureau of International Security and non life non-proliferation, which is which their goal is to prevent the spread of weapons of mass destruction, delivery systems, and advanced conventional weapons capabilities, where they track, develop, implement effective response to proliferation threats, and shapes the international security environment to prevent their recurrence. And that's it for me.
All right, thank you, Joseph. So with all of this presentation and with all of this research, actually, the question is, what is the outcome and conclusion? I mean, why are we here? Why are we even researching into this topic? Well, the simple answer is that we want to make engineers more aware and more cognizant of how these technologies that we are working on can impact the environment. I mean, I know that war is not generally seen through the lens of its environmental impact, and there's an argument to be made that there are more important things than a war's impact on the environment, like human civilian casualties and etc. However, this is just a new perspective that we wanted to give regarding the impact of war on climate change, because this impact is quite unprecedented. And as Joseph had already mentioned before, that just because of military activity, the carbon emissions is almost as much as the four countries with the highest carbon footprint, right? So it is very important to look at war from this lens as well, because obviously the impact is big enough for it to be noticed. So, just to summarize everything, we discussed that warfare does have increased rates of emissions because of bombardment, but also because of other alternate forms of warfare which rely on unsustainable technology. Either that unsustainable technology comes in the form of hydrogen fuels used for hypersonic missiles, or um, deadly pathogens which can harm biodiversity and ruin entire ecosystems, or is cyber attacks, which can actually shut down sustainable means of operation, forcing us to rely on unsustainable forms of fuel to function as a society. And lastly, we also discuss some of the ethical dilemmas that engineers faced working on these weapons, and some of the political treaties and political motives that can be taken to limit such large-scale destruction. As as my friend Rodrigo just mentioned, some of these political procedures are peace treaties, and obviously, peace treaties, like Rodrigo also mentioned, they are often not seen as the best case scenario, and nations are going to go to war anyways. That's just the inevitable sad reality of the situation. However, if there is a need for defense procedures. I know Andre mentioned the just war theory, but compact forms of warfare, which do damage on a smaller scale and it has minimal destruction, can also be taken into account. And these include surgical strikes and more targeted defense. An example of this would be the surgical strike which the Indian military did on Pakistani military sites, which led to minimal actually no civilian casualties and even minimal soldier casualties. And obviously, it did not do a large scale destruction on the environment as well. So that is definitely one form of defense that many countries could deploy. But as engineers, these are more political side this is more political side of things, but as engineers, what we can do is that we can take a stance, and awareness is, I believe, the first step to taking a stance. And this is why that this was our entire research proposal and our research project. And that is because as engineers, we should see we should see war from this lens, and we should understand that the technology that we're evolving for warfare has this detrimental impact on the environment. Therefore, abiding by the NSP Code of Ethics and just even human morality, taking a stance is one of the best things that we can do as engineers, and we should not be afraid to stand up for whatever we think is right while working on these technologies, all while ensuring that scientific development is made. I guess that is all from our group. Thank you so much for listening to our presentation, and these are all the references.
And so